Welcome to another session of the 2020 GovHack Virtual Conference. We're a festival of ideas using open government data to make our communities better places. GovHack is an international competition for people of all abilities who seek to make life better through open data. In a few weeks' time, on the weekend of the 14th to 16th of August, thousands come together in what has become one of the world's largest open data competitions. We're hoping to deliver an experience through YouTube. So if you're viewing the embedded video on our hackerspace, you can either click on the title at the top or the YouTube logo at the bottom to open up the video in a new window and join the conversation in the chat. We have two AWS sessions this evening. We'll have Linda Eitelberg, Solution Architect of AWS, with an introduction to artificial intelligence, machine learning on the AWS platform in about 30 minutes' time. Before that, we have Ash Wallace, Solution Architect at AWS, with an introduction to cloud computing and AWS Basics. Welcome, Ash.
Thanks, Matt. And thank you so much for your time today, everyone. And what a privilege it is for AWS to be a sponsor and to be a part of the GovHack journey again this year. We're thrilled to see the awesome things that you will build, and I hope everyone is coping well with their COVID-19 circumstances. So my name is Ash Wallace, and I'm a Solutions Architect at AWS. It's my job to help the public sector innovate with cloud and build awesome outcomes which connect with citizens. Over the course of GovHack, you'll have the opportunity to work on many challenges. So we'll be talking to you about a few topics which should help everyone through their solution journeys. Today we will start simple, since there is a variety of age groups and technology experience across the GovHack participants. And this evening, I'll be talking to you about cloud fundamentals and a few AWS technology tips to help you through GovHack. My colleague Linda will also be joining us this evening to talk to you about her recipes for handling data on AWS and taking advantage of our artificial intelligence and machine learning services. And next week, on July 28th, we will host another session covering analytics, visualization, and rapid web app development demonstrations on AWS, so don't miss out. Now, AWS will have staff available to help you solutionize through the GovHack event, and participants will be able to connect with AWS staff in a number of ways. Primarily, participants should be using Slack to collaborate and join the GovHack HQ workspace shown on our screen. AWS will be in at least 2 chat rooms. The first one to talk to AWS with all your questions and answers. And yes, we will have vouchers available for participants to use on the AWS cloud. So be sure to chat to us in the AWS credits channel. Secondly, the GovHack organizers will have a Zoom channel that will be created for the event weekend. This should be used if chat-based help doesn't give you enough support, or instead you need to have some face-to-face time to dive deep with AWS. The URL for the Zoom meeting will be created about a week out from the competition. So look out for that one over the coming weeks from the organizers. You may have noticed there is also a chat section this evening. So Linda and myself will strive to answer any questions after our sessions on the YouTube chat. Now, with that out of the way, let's get started with AWS Cloud Fundamentals. And firstly, you might be wondering, how did an online bookshop get into cloud computing? Amazon had realized they had developed a core competency in operating massive scale technologies and data centers to support the popularity of the e-commerce platform, which you may know as Amazon.com. So we embarked on a mission to deliver the same experience and success to any person and any business so they can build sophisticated, modern, and scalable cloud solutions. Amazon Web Services, AWS, was founded, and now Amazon.com itself is one of millions of AWS customers. Now, Amazon is unique in how we operate. We're unusually long-term oriented. You won't see our staff show up at customers at the end of quarter or the end of year trying to harass people into a sale. Everything we do starts with our customers and works backwards from their needs and their challenges. We like to hire builders who look at customer experiences or processes that have challenges, and we want to figure out how to reinvent those. We are inventors and we are pioneers of cloud, and we hire people that are a little bit peculiar and who want to build the new normal. So what is cloud computing? It's a great question and a topic of great debate as well. Here's our definition, unless you know a better one. It's the on-demand delivery of IT resources with pay-as-you-go pricing. Simply acquire resources such as compute, storage, networking, enterprise apps on an as-needed basis with no licensing handcuffs. But there is also modern technologies such as big data analytics, IoT, artificial intelligence, machine learning, serverless, API services, just to name a few. And these resources are self-managing and can scale instantly. Businesses only pay for what they use. We make them easy to consume from the application layer down. Now, historically, technologies like these were only available to big businesses with deep pockets. But with cloud, they are now available to anyone, all at a fraction of the time and the cost previously required. And AWS manages and maintains the technology infrastructure in a secure environment, which businesses access via the internet or via private connectivity. AWS lets customers quickly spin up resources as they need them, deploying hundreds or even thousands of servers in minutes. This means customers can very quickly develop and roll out new applications. And it means teams can experiment and innovate more quickly and more frequently. If an experiment fails, you can always deprovision those resources without risk. And if you look at how people end up moving to the cloud, almost always the conversation starter is cost. AWS allows customers to trade capital expense for variable expense and only pay for IT as they consume it. And the variable expense is much lower than what customers can do for themselves because of AWS's massive economies of scale. A great example of this is the CSIRO. They're finding disease genes with serverless functions on AWS. The solution does not pay for compute infrastructure to sit idle during periods of low or no use. Now, when you stop and think about this for a moment, it is a total paradigm shift from classic high performance and research computing data centers, which cost a lot to implement, maintain, and you have to scramble to get schedules and computing time. Periodic price reductions are also a normal part of business for AWS, and there has been 80 since our inception. We expect to continue to lower our prices this year and for many years to come. Our pricing philosophy is to work relentlessly to take cost out of our own structure and pass these savings back to AWS customers in the form of lower prices. Now, before cloud, customers used to over-provision to ensure they had enough capacity to handle their business operations at the peak level of activity. Now they can provision just the amount of resources that they actually need, knowing that they can instantly scale up or scale down along with the needs of their business. This also reduces the cost and improves the customer's ability to meet the end user or their own customers' demands on their infrastructure. The cloud allows customers to innovate faster because they can focus their highly valuable IT staff on developing applications that differentiate their business and transform customer experiences instead of the undifferentiated heavy lifting of managing infrastructure and data centers. AWS enables customers to deploy globally in minutes. We have the concept of a region, which is a physical location around the world where we cluster data centers together. We call each group of logical data centers an availability zone. And using AWS, customers can leverage 76 availability zones across 24 geographic regions worldwide, and we don't plan on stopping there. Now, security is job zero at AWS, but it is also a shared responsibility. We take care of security of the cloud, and it's AWS customers' responsibility to build secure applications. Our scale allows significantly more investment in policing and countermeasures than large companies can afford themselves. And on AWS, customers have access to a deep set of those cloud security tools with more than 200 security, compliance, and governance services and key features. A great example of this is Amazon GuardDuty. It's a threat detection service that continually monitors for malicious activity and unauthorized behavior to protect your AWS accounts. Now, you don't have to take my word for it. We will all be using Slack software to collaborate during GovHack, and in Slack's words, hosting Slack in AWS makes our customers more confident that Slack is safe, secure, and always on. AWS does a much better job at security than we could ever do running a cage in a data center. Now, AWS has more services and more features within those services than any other cloud provider by a large amount. 90% of what we build is driven by what our customers tell us what matters. And the other 10% are things we hear from customers. We read between the lines and we invent on their behalf. And while having over 1 million active customers is an enormous milestone, it is only through that journey where we have experienced the hard-earned lessons of operating and innovating at scale. And machine learning, it's in our heritage. For example, the recommendations you receive when you shop on Amazon.com, or our recent COVID-19 distancing assistant, which is open sourced and available online to help businesses and organizations help maintain social distancing with smart cameras. Now, in the fullness of time, virtually every application will be infused with machine learning and artificial intelligence. Tens of thousands of customers are already running machine learning on AWS, spurred by the broad adoption of Amazon SageMaker, which Linda will tell you a little bit about later this evening. Now, in a space that's moving as fast as the cloud is, to be partnered with the company that has the most functionality, iterating the quickest, has a massive community, and the pioneers of cloud from the start, that's very attractive for customers. So with the AWS Cloud Fundamentals out of the way, I was reflecting on former years' GovHack challenges and the exciting solutions that were built and how they can run effectively in cloud. Now, cost and time are usually your biggest constraints in a hackathon. And generally building and managing servers before you even get to your app and data logic, it's pretty time consuming. So to overcome this with AWS, we recommend you use cloud-based managed services and serverless technologies so you get the opportunity to save on cost, make the best use of your time, so you get to focus on your application and data logic instead of building and managing servers. So I'm going to impart a few suggestions to help you on your building journey. The first tip is, of course, use a managed service. Most builders are developing locally before running at scale in cloud, and we are making their code portable with containers. Therefore, you should use AWS Fargate, which removes the need to provision and manage container infrastructure, and you pay per container so you can move quickly and save cost. Another popular approach is to run code directly in response to events, such as a new file being stored, which can trigger access to analyze its data. You can trigger off a variety of events, such as incoming HTTP requests, queuing coming and going, pub/sub messaging, and so much more. And for these use cases, AWS Lambda lets you run code without provisioning or managing servers, and you only pay for the compute time that your code consumes. Next up is how to handle your data storage. Now, Amazon S3 is an object storage service, but it is so much more than that. It can host your website assets, or you can query the data in your S3 bucket as though it is a relational database with tools like Amazon Athena without needing to run an analytics computing fleet. Now, I can see this being highly cost-effective and scalable during the world's biggest open data hackathon, GovHack. Also, there's Amazon DynamoDB, which is an on-demand NoSQL key value and document database for any scale workload. No servers to manage. Simply create your tables and start getting and putting items from it. Very useful for modern web application development, or if you have application processing logic you want to bring along to a large amount of key value pair data. There is also a variety of managed application integration services, which you can use to build cloud-native workflows and applications, such as Amazon EventBridge. It's an event bus that ingests data from your applications, third-party applications, and even goings-on within your AWS account. And it's going to route that data to a target of your choosing, such as Lambda, for example, which we heard about earlier. Or you can use our API gateway and AppSync services to create and publish RESTful, HTTP, and GraphQL APIs to support your applications. We have Amazon SQS for messaging and SNS for pub/sub messaging, both of which are vital for communication between your microservices and computing tasks. Lastly, we have step functions, which can help you orchestrate sophisticated AWS serverless workflows. Now, all of these things you see here are fully managed services. So we take care of availability, the scaling, load balancing within an AWS region. So you're saving time, getting reliable infrastructure, and in terms of cost, all of these use variations of request and time-based pricing, which can be very effective during the short hackathon period. The only exception here I will call out is Amazon RDS. It's a relational database service, and I know some of you won't be able to resist a good old database for your needs during GovHack, and that's okay. Now, while RDS does make it easy to set up and operate a relational database in cloud, stick to things like Postgres, MySQL, and MariaDB variations to save on special database costs. But just know that it doesn't use the request cost model like the other services you see on this page. It's based on the count of database servers instead. So make sure you connect with us over the GovHack Slack workspace so we can help you stay cost optimized and agile in your delivery. The next tip to help you hack is for any web applications you may need to create quickly. We know web app developers and hackathon participants have pressure to build and ship at high velocity. So the goal of Amplify is to make it quick and easy to incorporate a range of proven services into your web applications. Amplify is a full lifecycle solution for developing, building, deploying, hosting, and even testing your mobile and web apps on AWS. It includes libraries, UI components, and a CLI that integrates the backend with the most popular web frameworks, such as React Native, React JavaScript, Angular, Vue, and other JavaScript frameworks and tools which developers use to build native apps. With just a few commands, you can have Amplify orchestrate a CI/CD pipeline for your web app, host your web app in the AWS cloud, and add important features such as identity services with AWS Cognito, and include those in your web apps very quickly so you can tie everything together. Now, lastly, this is the last you'll hear from me tonight. I wanted to show you an architecture pattern to handle your data needs. Firstly, land your raw structured data into Amazon S3. In the context of open data, GovHack, and analytics, it's cost-effective and highly performing alternative to a classic Hadoop file system deployment. And S3 has broad support in the analytics ecosystem. You can then catalog and transform your raw data sets with AWS Glue and send the curated data sets back to S3 as many times as you need. You can then use Amazon Athena to query your data set from the S3 bucket using SQL in order to surface it to any upstream analytics, artificial intelligence or machine learning, and reporting layers such as Amazon QuickSight. Now, I have left data analytics and AI ML intentionally vague here. It's a pretty sophisticated ecosystem with a variety of needs for how data comes and goes and gets presented back. We have a variety of services to help many skill levels from cloud practitioners right up to data scientists in the AI ML space. And Linda will talk to you about that next. Using these patterns, you'll be able to focus on hacking your open data sets instead of building and operating infrastructure to support your needs. Now with that, I challenge you to be serverless in everything that you build. Thank you so much for listening in to AWS Cloud Fundamentals and Hackathon Tips. And I'll now hand over to Linda, who will talk to you about her recipe for approaching data, analytics, and AI/ML in AWS. Thanks so much. And over to you, Matt.
Thanks, Ash. Yeah, next up, we've got Linda, who will do the next presentation. Thanks, Linda.
Thank you. So yeah, I'm going to talk to you a little bit about data. And as you probably know, we generate more data than we ever have before. So part of this hackathon, we'll be working with data to gather some insights. And what I want to do in the next half hour is give you an overview of how you can use data in in AWS. So I'm going to give you a lot of information and talk about quite a few services. And there's no need for you to use all of those services in your solution. What I'm trying to do is give you enough information so that you can make an informed decision on which service is useful for your use case in your project. So first, I'm going to talk a little bit about the data lifecycle and the services that are useful in that data lifecycle. And then I'm going to talk about some AI/ML services, from services that can be used by people with absolutely no machine learning expertise to services that are useful to people with a lot more experience. So what I'm going to start with now is the data lifecycle. So when data is generated, to be able to use this data, you need to move it from its raw form to a little bit more processed form. And the outputs of this data or this processing should enable end users to make better decisions. So all data will go through this life cycle, but often in example projects, you're shielded from some of these steps. It's really important to remember that bad data equals bad models. You can't generate good models from bad data. So you really need to process your data to get it into a form that works for your story and for your analysis. But before you start with the data lifecycle, there's another stage to consider. And these are the objectives. So it's really important for you to think about what you would like to achieve before you start. Often even data scientists are eager to jump into the data and start producing insights, but that can often lead to a solution looking for a problem. So what you need to do is you need to start with a clear user story and clear objectives before you get lost in the data. And you also need to think about how these objectives are achieved. So you might use machine learning, you might do some data analysis, and sometimes even a simple mathematical formula will do the trick. So once your objectives are clear, then you can start looking at the rest of the data lifecycle. And the first part in that is data ingestion. So data ingestion basically means you're ingesting data from an external source into another location for further analysis. And generally, this location is either storage or a database, but I'll talk a little bit more about that in the data staging stage. Your key questions for data ingestion are: what is the volume of the data? And what is the velocity of the data? And by what is the velocity of the data, I mean, is it batch data? So are there chunks of data that then you may be able to use a simple copy command to S3? And I'll talk more about that in data staging. Or is it high velocity data? Is it streaming data? And an example of that would be application logs or website clickstream data. So if you have high velocity data, we have a service called Amazon Kinesis that you can use to ingest data that is high velocity. In these stages of the life cycle, I have a bunch of services in these pictures, but I've only chosen to talk about the ones that I think may be useful to you in this challenge. So the first one is Amazon Kinesis. So Amazon Kinesis makes it easy to collect, process, and analyze real-time streaming data. You can process and analyze the data as it arrives and respond instantly. So you don't need to wait to collect data before you can do that. And some of the capabilities of Amazon Kinesis are Kinesis video streams to ingest videos, Kinesis data streams to stream real-time data so that you can use that for real-time analytics, Kinesis data firehose to capture, load, and transform streaming data into things like data lakes, data stores, and analytics tools, and Kinesis data analytics that enables you to do real-time data processing using SQL or Java. And you can integrate your Kinesis data streams into your Kinesis data analytics. So the next thing I'm going to talk about is data staging. Data staging basically gives you the opportunity to perform data housekeeping and cleansing before your analysis. So the key question in data staging is, what are your use cases? What is the structure of your data? And what is the size of your data? In an organizational setting, you'll often have lots of data, and then you need things like data warehouses or a data lake in S3. And data lakes basically make it easier to handle the data access and the security. And I'll talk a little bit more about S3 later. But for this challenge, you're more likely to use something like a database or some object storage. So the first kind of database I'll just mention is Amazon RDS. So Amazon RDS is our managed relational database in the cloud, and it gives you a resizable MySQL or Postgres database. Ash has already mentioned Amazon DynamoDB, but I will talk a little bit more about this key value database here. So I've used DynamoDB streams in application design before, and that's why I wanted to mention it here. So it's serverless, it's pay-as-you-go, it has built-in security capabilities, and it has built-in backup and restore. But the really amazing thing in application design are these DynamoDB streams. So DynamoDB streams basically lets you capture changes in your DynamoDB table, and it stores these changes for up to 24 hours in a stream. And you can integrate these streams with AWS Lambda to create triggers, which are pieces of code that let you automatically respond to events in DynamoDB streams. And this allows you to build applications that react to data modifications in your DynamoDB tables. And then you have Amazon S3. So Amazon S3 is our extremely durable object storage, and you can use it to store and retrieve small or vast amounts of data. So you can access your data using the AWS Management Console, using the Application Programming Interface, and the AWS Software Development Kit client, which means that you can integrate your data from S3 with your application using an API call. It is secure by default, so if you're making your objects in S3 available to other people, you will need to change the settings from the default settings. And an example of that would be if you're hosting your static website in S3, you will need to change your settings to make it world readable. You can also use standard SQL expressions to analyze your data in S3 using Amazon Athena. And I'll tell you a little bit more about how that works in a later stage. So the data in this challenge will likely already be staged, but there's still work to be done. And the next step from data staging is data cleansing. So before analyzing it, the data, you need to cleanse it to prepare it for analysis. And you can use that, you can use an ETL function. So that's an extract, transform, and load function. And basically what an ETL function does, it converts information into usable data for your destination system. So the format that you want it in depends on your destination system. An example of that might be where you have a date-time format in a field that needs to be changed into a different format to be processed by your analytics program. You might also want to merge data from different sources and align the formats. So the key question you want to ask yourself when you're cleansing your data is, what are you doing with the data? And which tool do you want to use for your ETL function? So when you're cleansing your data, you also need to think about whether you're using it for analytics or machine learning, because you need to be more thorough for analytics than for machine learning. So as an example, when your outliers are data points that differ significantly from other observations. And when you're using analytics to just have a look at your average user behavior, these outliers may skew the data and give you a bit of a mistaken view of the average user behavior. But when you're using machine learning to predict events based on user characteristics, once you've determined that those outliers are not errors in measurement, these outliers could be incredibly important and And you may determine based on those outliers as well that you may need to collect more data. So a really handy ETL tool we have is AWS Glue. Now, AWS Glue is a fully managed ETL service that allows you to prepare and load your data for analysis. So to create and run your ETL job, you need to point AWS Glue to the data stored on AWS. So the sources can be SQL databases, Amazon S3, and Amazon DynamoDB. So when you're cataloging your Amazon S3 data using AWS Glue, you can make it available for querying with Amazon Athena. And that's how the querying your data using SQL with Amazon Athena works. And finally, we'll have a look at data analytics and visualization. So analytics basically means that you're generating results from your data, and visualization allows you to explore your data and communicate those results from your analysis to your target audience. And the key questions that you want to ask yourself are, who are the consumers of the data? And are the results and presentations aligned with the desired use case? Do your consumers find your output compelling, understandable, and actionable? One of our analytics tools that I've mentioned already is Amazon Athena. So that's a serverless interactive query service, which makes it easy to analyze your data in S3 using standard SQL. Being serverless means there's no infrastructure to manage and you pay only for the queries that you run. Another really handy tool for visualization is Amazon QuickSight. So Amazon QuickSight lets you create and publish interactive dashboards that can be accessed from your browsers or from your mobile devices. And you can embed these dashboards into your applications. And you can scale to tens of thousands of users. So there's no software to install, no servers to deploy, no infrastructure to manage. And as an added bonus, you can use machine learning powered anomaly detection to discover hidden trends and outliers in your data. Now, I'm going to skip over data archiving because this is not a long-term challenge. But if you do want to have a look at data archiving, you can have a look at Amazon S3 Glacier. So another way of gathering insights from your data is AI and ML. So let's start by defining AI and ML. Colloquial artificial intelligence is defined as describing machines or computers to mimic cognitive functions, which are functions that humans associate with the human mind, such as learning and problem solving. So widely accepted textbook definition of artificial intelligence is the study of intelligent agents. And an intelligent agent is any device that perceives your environment, takes actions, maximizes the chances of successfully achieving its goals. So machine learning is a subset of artificial intelligence. And in a nutshell, machine learning enables computers to learn tasks that it is not specifically programmed to do. And I'm going to give you two distinctions in machine learning, but before I do this, I'm going to define some terms. Classification is the identification of categories for your observations, such as a person that voted or a person that didn't vote. Labeling is tagging your samples with labels, and that can be something like a picture where you want to tag items in that picture as either a duck or a fish. So unsupervised learning, there's unsupervised learning and supervised learning. And unsupervised learning means that the information that your model trains on is neither classified nor labeled. So you'll be modeling your underlying structure or the distribution of your data to learn about your data. And an example of that is clustering your data based on characteristics. So As an example, when you may have some data on people who voted, and the only thing you know about them is that they voted, but you also have some characteristics of these people. And you might just want to group the voters by characteristics to learn about them. And then supervised learning means that you have labeled examples that you can learn from. And in this example, you might have observations of people who voted and people who didn't vote. And then you can use those observations to make predictions on whether a random person is going to vote or not. So let's have a look at the AWS machine learning stack. The AWS machine learning stack, this is the AWS machine learning stack. And so we have both services in AI and ML. And we define the stack as top layer, middle layer, and bottom layer. So let's first look at the top layer. The top layer consists of services that can be used without artificial intelligence expertise. For some services, it helps to have a broad understanding on what the underlying model is doing to be able to effectively use the service. And an example of that is Amazon Personalize. But I'm going to be talking about two services where you don't need an understanding of what the underlying model is doing. The first one being recognition. So Amazon Recognition lets you add image and video analysis to your applications via the console or an API call or via the software development kit. So it uses machine learning to extract information from images and video. And it's not 100% accurate, so I can happily report that it regularly underestimates my age, but it is great at recognizing figures in images. So recognition comes with built-in functions that enable you to recognize things like facial analysis of a person without training. So as I mentioned, one example is facial analysis, like the age of a person or how happy they are. Another example would be recognizing text in an image or object and scene detection. But you can also use custom labels in recognition. So when you're using custom labels, you'll have pre-trained models, so they'll be trained in pattern recognition, and you just need to train them a little bit more to suit your use case. And some examples of these are recognizing products in a catalog, recognizing custom icons or logos and symbols. But my favorite example here is recognizing whether a cucumber leaf is healthy or infected. And what I'm imagining here is having a drone flying over a huge field of cucumbers, taking pictures and somehow sending them back to recognition to be able to see whether those cucumber leaves are healthy or infected. So another service that doesn't require machine learning expertise is Amazon Forecast. So Amazon Forecast is a fully managed machine learning service that allows you to combine time series data and additional variables to build forecasts. So time series forecasting is basically a technique that lets you predict future time series data using historical data. Amazon Forecast lets you automatically examines the data and identifies meaningful insights and produces a forecasting model that is capable of making predictions. And an example of that could be resource planning, such as raw material for manufacturing. Amazon Forecast implements technical and physical controls, such as encryption at rest in transit, and you retain the ownership of your content. It's a fully managed service, so you don't need to provision servers, but you also don't need to train or build or deploy your machine learning models. And you pay for what you use, as it's fully managed and serverless. So forecast behind the scenes. What you do is you provide historical data and any additional data that you believe will impact the forecasts. And so the related data could be if you're trying to forecast the items, how many items will be bought. You might have the price, you might have promotions. And then there's item metadata that could be things like the color of the item. So what you need to do is you need to load your data into S3, and there's some documentation on AWS that is prescriptive of the format. So there's some reserved field names in the documentation that you need to keep in mind that you can't use yourself. You need to cleanse, ingest, and stage the data into S3, but from S3, it can be loaded into Forecast and make predictions. So Forecast will ingest your data, train the model, provide accuracy metrics, it'll perform the forecasts, it'll identify the features, it'll test for different algorithms, and it'll select and tune your parameters. It will also host your model so that you can call the API and take advantage of the forecasting model that you've created to make predictions. So these are some of the services on the top layer. So let's have a look at the middle layer of the AWS ML stack. And this middle layer is dominated by Amazon SageMaker. So Amazon SageMaker makes it easier for everyday developers and data scientists to build, train, and tune the machine learning models. Amazon SageMaker is a fully managed service that provides all the components used in a machine learning model within a single tool set. So it has the tools to build and manage data sets, to choose or build your algorithms, to train or tune your model, to deploy and manage your trained model. I could spend an hour talking about the SageMaker services and still only give you a broad overview. But I just wanted to make you aware of this amazing and versatile tool and what you can do with it. So right from the get-go, you have access to a fully managed machine learning notebook environment, and that's the Jupyter Notebook environment. You can use ground truth to build highly accurate training data sets. So ground truth uses machine learning to reduce your data labeling overhead. Once your data is labeled, ground truth can learn how to label it using machine learning with corrective mechanisms. You can use SageMaker to choose and implement your desired algorithms and frameworks. So we have teams at AWS that optimize the top algorithms so that you can use them in SageMaker. And using SageMaker means you don't need to install, configure, or handle drivers and frameworks. We have native optimization with TensorFlow, MXNet, Chainer, and PyTorch. And you can also bring your own algorithms and frameworks. And then there's the training. So to train your model, you specify the location of your data in S3 and your instance type. So you can use one instance type for your notebook, and then you can beef up your training using a Meteor instance type just for the training. So as an example, I trained a model to detect whether people were wearing hard hats or not wearing hard hats. And there was no need for me to create my own neural network to train on images. I just called the object detection algorithm created by AWS, and it did its magic. So the algorithms in there are optimized for efficiency and for cost and time savings. So at university, I created my own reinforcement learning algorithm, and that took me a long time to write code and it took a lot of resources to run. On my computer, I would have run it for a few months for all the training that I needed to do, but I did take advantage of AWS and its EC2 instances. It took a long time, so it took a long time to write and create, and any SageMaker reinforcement learning algorithm will put my model to shame in speed, cost, and effectiveness. I can train a model in a few hours that uses as much data as I had to train. That trains on as much data as I did on my uni model, and it is just so much more efficient. I will never create my own reinforcement learning algorithm again. So once you've trained your model, what you want to do is you want to optimize your model. And so I've talked about hyperparameters already before. So hyperparameter optimization. In machine learning, you have hyperparameters, and these are parameters that are used to control the learning process, such as the learning rate in reinforcement learning, which defines how much an algorithm weights new observations versus old observations. So when you're optimizing your hyperparameters, you're trying out different iterations to find one that works best for your data and your outcomes. And using automatic model tuning in SageMaker, you can do the hyperparameter optimization yourself. And again, at uni, hyperparameter optimization was the bane of my existence. I had to train a model, let it run for a few hours, train it, write down the results in a spreadsheet with the different values of the hyperparameters, and then train another model, and then train another model to get the most optimized hyperparameters. And it only improved it by a little bit. So I'm a big fan of automatic model tuning. So once you've tuned your model, you can deploy your model into production. And that basically means picking an instance type and a minimum and maximum number of EC2 instances to deploy your model on. So once you've deployed it into production, SageMaker manages the compute infrastructure. It performs auto-scaling based on the minimum and maximum number of EC2 instances you've defined. And it performs health check, it handles node failures under the covers, it applies security patches, and it performs other routine maintenance. And then there's the bottom layer. So I won't spend any time on the bottom layer of the machine learning stack, only to say that it is for expert data scientists working at the framework level. And you can integrate that bottom layer with Amazon SageMaker. So for those of you who don't know Duolingo, it's an application that you can use to learn languages. And Duolingo used deep learning, which is a subset of AI and machine learning that uses neural networks to mimic a brain's behavior to quickly analyze data and make intelligent predictions. So they use those deep learning algorithms in natural language processing, where they analyzed user log data to predict the likelihood that users would get their answer correct. And they use those predictions as a basis for personalizing both their adaptive learning tests and their content in their learning app. Now, Duolingo makes more than 300 million predictions every day using the PyTorch deep learning framework in AWS. Great, that's the end of it.
Thank you, Linda.
You're welcome.
It was a very interesting presentation to go through, both of you. Thank you, Ash, as well. It was good to have the introduction to the cloud and AWS there. I know we've got a lot of competitors every year that come along that haven't had a lot of experience here. So we do cater for everyone. So the idea is that anyone, regardless of your technical ability, can join in. So it was very good. Thank you. And good to hear that the free credits are happening again. So I know it's a popular question that always comes up from the competitors on the weekend as well. A couple of things. So you did mention the things. I've used it myself before, the Lambda, DynamoDB, and Lex. Didn't speak of it so much there, but using some of the machine learning in my GovHack entry a couple of years ago, I've done myself. So it was really interesting to hear about the ag tech as well, the cucumber leaves and everything you were speaking out there. So thank you very much. We've got the GovHack conference going for the next 2 weeks. We do have another session tomorrow evening at 7 p.m, which is the Hacker Mindset, which is design thinking by Hackathons Australia. And don't forget, the 14th to 16th of August is our competition weekend. More information on our GovHack website about that. But thank you again, Ash and Linda.
Thank you.
Thanks for having us, Matt.
Thank you.